working at 9.4, we had one example left to take a look at. And so we're going to finish up with that one example about odds and expected value, and it is an expected value problem. So example number 6 says, if you were looking at your textbook, this is what it's referring to, there's a cartoon at the beginning of the section, and it says the odds against winning the lottery are 55 million to 1. So the first question we're going to ask relates to the idea of odds and probability together. So if the odds are, odds against winning are 55 million to 1, what is the probability of winning? That's close. There you go. 1 over 55 million and 1. Did I get that written right? Okay, so a reminder with the way odds work is that if you're taking a look at odds and you have this 55 million to 1, what that's actually referring to, if you combine them all together, is that 55 million and 1 person plays the lottery. 1 wins, 55 million lose. That's what odds is looking like, right? So the 1 is the number that win, 55 million is the ones that lose. So we have 1 over 55 million and 1 as our probability for winning the lottery. B says if the grand prize is $13,567,290 and the ticket costs $1, is the game fair? All right, so does anybody remember what fair meant when we did this before?
Just as good as the expected value.
Close. It means the expected value is 0. Okay, so it is related to expected value. So the expected value of the event being 0 means the game is fair. That means that you're equally likely for you to lose as to win in terms of how much you paid to play. You're relating it to how much gain or loss you have when you play the game. So when we're finding the expected value, this is what we're looking for, is to see whether or not the expected value equals 0. That's our question. So in order to find out if that happens or not, we need to figure out what the expected value is. Make sense? Okay, so expected value is comprised of however many things can happen times the likelihood that they can happen. So in this situation, there's only 2 things that can happen. What can happen? You win or you lose. Now that's not the case with all games like this. Sometimes there's a first prize, second prize, third prize, right? Like that happens. You're going to see some of those in your homework. So when you look at that case, there's not just 2 things that can happen. But on this one, there is 2 things that can happen. Let's take a look at the probability, or at the winning scenario. So, if you win, what do you get? How much? Is it 290? Is it 291? Wendy says 289. Why is it 289, Wendy? Yeah, you did. You played $1 to play the game. So you paid the $1 to play the game, which means you lost that $1. And then when you won, you want to think about the net change in your checking book, or in the account or your wallet or whatever. Okay? Yeah, so it's 89. How likely is that to happen? How likely are you to win?
Not very.
Not very. What is that?
1 in 55.
Part A, right? One in 55 million, 1. Okay, so that's the winning side. What's the other option? You lose. And when you lose, what happens? You lose $1. So what is your value if you lose? -1. How likely is it that you lose? 55 million over 55 million and 1. Yes. So before we go through calculations, does everybody see where the pieces came from? Any questions about those pieces? Okay. So I need to calculate this, right? And your calculator is a wonderful tool because these are ugly numbers. Certainly not going to keep this in fractional form for several reasons. Number one, because these are ugly numbers. Okay. Why else would it not make sense to keep this in fractional form? It's talking about money. Yeah. We don't talk about money in fractions. It's just that's not what we use when we converse about our money, right? Nobody says I have 2/5 of a dollar in my pocket. Do they? No, you wouldn't do that. That would be 2 dimes, by the way. Wait, 4 dimes, by the way. So we don't talk like that. We even get confused thinking that because that's just not how we talk. So it wouldn't even make sense to do this in fraction form. So did anybody get a calculation value for this? You're working on it? When you guys do group work, if you have your confusion on how to enter this in your calculator, you let me know and I'll show you how to do it with your calculator specifically. Did you get one? What did you get, Brennan? I have a slightly different answer. Oh, no, I'm sorry, I'm on the wrong page. You're right, that's what I have for my answer. Notice I put something besides just -0.75, what I put? A dollar sign, because we are talking about money. So what this is saying is, on average, every time I buy a lottery ticket, on average, right, I lose 75 cents. That's what this is saying. Okay. Is everybody good with that? Because we're about to change the problem a little bit. What's that?
So I'm not okay with losing something.
No, I'm not either. There's good reason to not play. All right, so here's where things should start to sound like things you've seen in real media before. As with many state lotteries, the proceeds are often said to benefit education. Under these conditions, if all proceeds benefit education and 1 million tickets are sold, what is the expected value generated for education from the lottery sales? Do you understand the question? So one person goes and they buy a ticket, and they expect, on average, for Part B to do what? Lose 70 from the perspective of the consumer. They lose 75 cents. So from the perspective of the lottery, they're making 75 cents. Okay, does that make sense? So on average, based on Part B, in this particular setup, the expectation is that every lottery ticket that's sold generates 75 cents worth of income to the state. Are you good with that? So if they sold 1 million tickets, how would we figure out how much money they made? Right. And in fact, Brennan, you had more than 0.75 in your calculator. Do you still have the decimal expansion that it gave you? However many it has? No, and it's positive now because we're talking about it generating the money from the state's perspective. You don't have it? Do you have it, Mackenzie? Okay. It's okay. We're going to go with what I have written down. That's what I have at my firm before. Okay, so I recognize the last problem we didn't include all those decimals since we were talking about money. But I'm about to multiply it by a million. So those decimals are actually going to end up not being decimals in the moment. All right, so one more time, Brendan, why am I multiplying by a million? Yes, that's how many tickets are sold, and that's where we started, right? Talking about how many tickets were sold. Okay, so if we multiply this, what do we get? $753,322. Oh. Did I write that wrong? Oh. I did. I think this is a 0 in here. I'm so sorry.
I got it. It's 0.75332200.
Okay, let me write what you have again. I think I just have one of my decimals off. 75, what was it?
332200.
Oh my goodness. Okay. So if I multiply by 1,000, I might end up moving my decimal 6 to the right. Okay. So I do have 753,322. Is that written right? I just have it written down wrong here. Yeah, and actually it would be 1 cent, wouldn't it? Actually it wouldn't, because this 4 would round down to a 0. So yeah, that's actually what we have. Okay. But it doesn't really work like that. That's not really what happens. What really happens is when the lottery happens, either somebody does win the jackpot of the 13 million, or nobody does. That's really what happens, right? This is an expected value on average over the long haul of the 300 million years we're doing this for, or whatever, that this would happen. But that's not really what happens. What really happens is either they sell the million tickets and nobody wins, in which case how much money is made? $1 million. Everybody with me? Nobody wins and everybody pays $1 per ticket. They really generated $1 million worth of income. Okay, so the actual possibilities. One possibility is that they generate $1 million, and this is the case when nobody wins. What's my second option? Somebody wins.
And they generate 7.
Do they?
They generate the difference.
Okay, think about what happened. 1 million people bought tickets. So how much money came in? $1 million. No matter which way you look at it, there was $1 million paid at the gas stations for those tickets, right? Okay, so there was $1 million to start with. But in this scenario, somebody wins. So then what happens? We take away how much the person wins. Well, what's that number? Did I get that written down right? 290 at the end, not 900. Do you see a problem? What happens on this? There went your education. Okay, so this gives you a negative, doesn't it? I get a negative 12,567,000. That's not quite right. Negative 12 million something. Or is it? Yeah, I was right. Yeah. And so they'll pay it on a payment plan instead because you don't have to pay the whole thing. So somebody, because then they would bankrupt education and heaven forbid, that isn't already bad enough, right? Okay, so here's the problem, right? The problem is that you said it was to support education, which means that if you want the money generated for education, then you want the people who buy the lottery tickets to lose. All of them. You don't want anybody to win. None of them. Okay? But everybody gets really excited when that one person wins, don't they? Or there's 6 people or whatever. Lucky 7. Is anybody watching it? Okay, good show. My husband's watching it. That's all I know. Show about people winning the lottery. Okay. So, yeah, but people get really excited when they generate this money and then it goes towards one person. You can't hold both views at the same time. Do you see what I mean? And this is often sold as a way to increase money for education. I don't know why everybody really likes that one. They want to promote education. But then they want somebody to win. So, all right, let me pull up the last slide so you guys can write down